if you had just literally gone through and predicted not spam for everything, you would have gotten 60% accuracy. So you do want to have this comparison of how good your accuracy is. And if you have data sets that are highly imbalanced, so at the end of every sports season, writers vote on an MVP, most valuable player. So you could have a data set that was every NBA player who had ever played, and you could have, the player, the season, some stats, and then whether or not they were the MVP. And there's only going to be one most years. So, and then you could try to build a classification model that predicts whether or not a player will win the MVP. Well, what's the problem with that? Yeah, if you just guess no for every player, like 99% accuracy. So if your data set isn't balanced, if you have way more of one class than another, you don't want this to work, because you'll just build something that just says no all the time. So if you have an event that's very rare, you need to address that. You also need to think about if there's a direction where it's better to make a mistake. So let's say you're trying to classify cancer, whether or not someone has cancer. So if you predict that they do, and then they go and get a better test and it turns out they don't, there is a certain cost associated to that in terms of time and testing. But if you predict that they don't and it turns out they do, that's a much worse mistake. So you would probably want to weight the one mistake differently than the other, make it so your model tended, if it was going to make a mistake, to make it in a certain direction. This is the last time that we'll just use .score unquestioningly. We're actually going to get into how do you assess performance and think about contextually. This is not a video game where you're just trying to move the number towards 1.0. It's something where you have to take the context into account.